Alright, in this video we're going to talk about lesson 1.4 day 2, reference angles. So a reference angle is going to be useful to help find trigonometric functions of angles that are not in quadrant 1. So ideally quadrant 1 is the easiest one to look at. Everything's positive, it's the smallest numbers, so if we can push everything to quadrant 1, our lives are going to be a little bit easier. Now, reference angles are going to be the angles formed by the terminal side of some angle theta. So the terminal side of the angle theta and the horizontal axis, or the x-axis. So sometimes our reference angles are going to be in quadrant 2, sometimes quadrant 3, sometimes quadrant 4, depending on where that terminal side lies. But our reference angle is always going to be with the x-axis. So the first example is going to be find the reference angles for the following angles. So a 300-degree angle, if we think about our unit circle, 300 is somewhere around here. So if we go around that way, so 300-degree angle. So the reference angle is going to be the angle formed between the terminal side and the x-axis. So that degree that's left, if there's 360 all the way around, if we've used 300, our reference angle, which is oftentimes called theta prime, is equal to 60 degrees. And we'll talk in a second about how we're going to use that 60 degrees to help us out. 2.3. Now notice this isn't 2.3 degrees, it's just 2.3. So we're in radians. We know pi is here. Pi is 3.14, so 2.3 is somewhere over here. So if we're thinking about the reference angle is going to be the angle made with the terminal side and the x-axis. So we're looking at this little bit here. So that angle, our theta prime, is going to be pi minus 2.3. Right? That's what's going to be left over when we do that. So if we want to put that in a calculator, you're going to get something that's approximately 0.842 is going to be the reference angle there. So whatever it takes to get to that x-axis. Now if we think about negative 3 pi over 4, so negative angles are going this way. So pi over 4, 2 pi over 4, 3 pi over 4 is right here. The reference angle there, again, we want to go to our x-axis. So we need to figure out how much room is there. So we got to think what's the distance. So our theta prime is going to be pi over 4, right? That's how much room it's going to take to go from here to here. So reference angles are basically going to turn anything into a first quadrant angle, but only for reference. Now how we're going to use these things is this way. So to find the trig value of any angle theta, what we first want to do is determine the function value for the associated reference angle theta prime. So the associated reference angle that we'll call theta prime. So the first thing we're going to do is we're going to find theta prime, we're going to find our reference angle, then we're going to find the reference or the trig function of that. So if it's asking for something like cosine of 4 pi over 3, we find its reference angle and take the cosine of that. Then, depending on the quadrant that we are in, we have to affix the appropriate sign to the function value. So cosine of 4 pi over 3, we should know that's on our unit circle what the value of that is. But using reference angles, if we want to, 4 pi over 3 is going to be down here. So we know that this reference angle here, theta prime, is going to be pi over 3. So if we think about the cosine of pi over 3, we're going to get 1/2. But we're in quadrant 3, so cosine has to be negative. So we're going to know cosine of 4 pi over 3 is going to be negative 1/2. Now again, this is just another way to do this problem. You should know what cosine of 4 pi over 3 is. That's in your unit circle. So this isn't saying you have to do it this way. It's just another way to think about it. So if we're going to look at this one here, cosecant of 11 pi over 4. First, we're going to want to think about where 11 pi over 4 is. So we know that these things have a period of 2 pi. So 2 pi is going to be 8 pi over 4. So 11 pi over 4 minus 8 pi over 4 is going to equal 3 pi over 4. So it's going to be in the same spot as 3 pi over 4, but you went once around the unit circle. Or if you didn't want to do it this way using our period, you can just count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 4. It's going to be in the same spot as 3 pi over 4. If we look at the reference angle, theta prime is going to be pi over 4. Cosecant is going to be 1 over the y value. The y value here, or I'm sorry, at pi over 4, so cosecant of pi over 4 is 1 over radical 2 over 2, which is just 2 over radical 2. If we rationalize, we're going to get just radical 2. Since we are in the second quadrant with this, sine is going to have the same sign, SIGN, positive, negative. So cosecant is going to have the same. So cosecant of not 3 pi, but 11 pi over 4 is going to be radical 2. And again, if this looks like way too much work, just know it on your unit circle and you're going to be okay. So we'll call it quits on that video, and we'll see you in the next one.